Hello, people. All right, so what I'm going to do today is some examples of the problems like you might see on independent events practice. In the last video, I talked about what independent and dependent events are, so if you need to check that out, please do so. So let's look at the first one. It says the probability of event A is 0.56 and the probability of event B is 0.34. If A and B are independent, then the probability of A and B is. So if they're independent, to calculate the probability of this and that, all you have to do, the probability of A and B, this is solely if they're independent, is equal to the probability of A times the probability of B. That's simple. So in this case, probability of A is 56 hundredths. The probability of B is 34 hundredths. Whoops, 0.34. You'll just plug those in your calculator, and that would be 0.1904. Okay. Let me go grab my calculator real quick. Sorry. My bad. All right, let's go to the next one. I do that all the time, right? A six-sided fair die is rolled and a fair coin is tossed. If event M represents getting an odd number on the die, and if event N represents landing tails on the coin, are these two events dependent or independent? And then they want us to calculate the probability of M and N. So when I roll a die, does it in any way, shape, or form affect what's going to happen when I flip a coin? The answer is no. They have no effect on each other. Therefore, they are independent. The probability of one does not affect. One probability is not affected by what happens by the other event. Me rolling a 6 has nothing to do with what I'm going to get when I flip a coin. All right, so now to calculate the probability, since they are independent, the probability of M and N will be equal to the probability of M times the probability of N. So the chances of me getting an odd number when I roll a die, so it's 1 through 6, half of them are odd, so that would be 3 out of 6 or a half. And then the probability of me flipping a tail on a coin is there's one tail, one head, so 1 out of 2. So that would be 3 out of 12 or 1/4. Or, as a decimal, 0.25. Or 25%. Okay? Let's do another one. All right, for this one, it says the probability that Roger wins a golf tournament, event A, is 0.45. And the probability that Stephen wins the tournament, event B, is 0.4. The probability of Roger winning the tournament given Stephen wins is 0. And the probability of Stephen winning the tournament given that Roger wins is 0. I'm guessing they're playing each other. Are these events independent or dependent, and why? So let's look at what we got here. We know the probability of A is 0.45, right? And then the probability of B is 0.40. Okay. The probability of Roger winning, knowing that Stephen wins, so the probability of A given B is equal to 0. And then the probability of Stephen winning, if we know Roger wins, is 0. So the probability of B given A is 0. So if these were independent events, if they were independent, then the probability of A would have to be equal to the probability of A given B. If they were independent, B happening wouldn't affect the probability of A at all. But when B happens, it changes that probability. So since the probability of A is not equal to the probability of A given B, And the probability of B isn't equal to the probability of B given A, these bad mama jammas are dependent. Let's see. What was I going to go here? They are dependent. Because if they were independent, one happening wouldn't affect the probability of the other. You know what I'm saying? All right, let's look at another one. Whoa, drop stuff on the floor. All right. The probability of drawing 2 aces from a standard deck of cards is 0.0059. We know this probability, but we don't know if the first card was replaced. If the 2 draws are defined as A and B, are the events dependent or independent? So we just basically need to figure out, did they replace the card or not? If they don't replace the card, then they're dependent because you've changed how many aces are in the deck and you've changed how many cards are in the deck. Whereas if you replace it, the number of aces and the number of cards stays the same. So if you do the probability with replacement, so with replacement, then your probability of A and B would just be A times B. So there's 4 aces and there's 52 cards in the deck. You put the card back, you draw again. There's 4 aces and 52 cards in the deck. And with replacement is independent. You didn't change anything. Now, if you do it without replacement, the first time you draw a card, there's 4 aces in the deck and there's 52 cards. But the second time, there's only 3 aces left and there's only 51 cards. So this would be dependent. We've changed things. It's affected my probabilities. So let's just multiply these and see if we get this, and we'll know which one it is. Okay? Let's do this one first. Clear. So 4 over 52, or 452, 50 seconds, times 4 divided by 52 gives me 0.0059, yada, yada, yada. Over here, just for fun, 4 over 52 times 3 over 51 is 0.0045, yada, yada. So this is this, therefore the card is replaced and it is independent. Independent. Y'all think about that song, that INDEPENDENT. That's just every time I write that word, that's all I can think about. All right, we good? Let's do one more. Okay. I don't know if I need this, so let's be prepared. The probability that Evan purchases a comic from the store, event A, is 0.67. And the probability that George purchases a comic from the store, event B, is 0.74. The probability that both Evan and George purchase a comic book is 0.2442. Are the events dependent or independent? So in my mind, the easiest thing to do is see if they're independent, and then if not, well, we know what it is, right? So if they're independent, then the probability of A and B should be equal to the probability of A times the probability of B. So we'll multiply these two bad mama jammas, see if we get this. If we don't, then booyah, it's got to be dependent. So that would be 0.67 times 0.74. Again, the handy dandy calculator, 0.67 times, I already forgot that number, 0.74. And that gives me 0.4958, which is not what this number is. They are different. So is it independent? No, it's not. It's got to be dependent by process of elimination. Boom, boom. right, I hope this helps. Have a fabulous rest of the day.